you will. All right, we're going to look at vectors part 1. If you're in physics, you may have talked about vectors a little bit. We're going to add to that, and then you'll be like, oh, this is really easy. So let's look at what a vector is. A vector is a directed line segment. That means it has a point on one end and an arrow, right? Because it's a directed line segment. It's customary to represent a vector with an arrow. The length of the vector is called the magnitude, and the arrowhead indicates the direction. So notice there's no arrow here and there's an arrow here. So I would say this is AB and the symbol is like that. If I had this vector would be BA because the arrow's at the A. You tend to want to write things alphabetical. So you have to look at which way it's pointing so that you have that the right way, okay? A directed line segment has an initial point and the terminal point. Thus, the piece with the dot is initial, and this is terminal. Okay, on this guy, this is initial because it has a dot, and this is terminal. And it's important that you can tell the difference between those, because when we do some vector operations, if you have them backwards, your signs will be backwards. Okay, so let's look at these 2 points. Let's say I gave you point P. We just graph it, right? I know that's P because it's blue. I'm going to do Q. Right, and now we draw in an arrow. And because they told us it's PQ, we know which side is terminal, right? Y'all, please make sure your screen is muted at home. I am hearing someone, but I'm not seeing who it is. All right, so we are gonna, this is PQ, so we go here and we draw an arrow. Q has to have an arrow because it came second. These little bars, when it says find PQ and it's got these 2 skinny bars around it, those bars represent magnitude. They won't ask you what the magnitude is. They'll just put those skinny bars. So you have to figure it out. Now, magnitude is represented by the length. So how are we going to find the length of this? How big is this piece right here? It's 5, right? And how big is this piece right here? 2. So what tool do you have to find out the hypotenuse of this triangle? Of course. So we would say it's C squared. So I'm just going to square root both sides. And it's going to be A squared plus B squared. So that equals the square root of 29. Okay. And this is the magnitude of that. So it's the size. How big is this? You're used to the word magnitude. We think about that with earthquakes, right? The magnitude of the earthquake. You think about it of problems. What's the magnitude of this trouble I'm in, right? So it's how big it is, the size. Okay. Now these numbers, the 5 and the 2, have special names. Those are called the components. So the horizontal component, and I'm going to change this to pink and do the vertical component. Okay, those are called the components of the vector, and that's just where you draw in your little right triangle. If this is slanted, then we draw in to make a right triangle so we can use the Pythagorean theorem. Here's your vertical component. Horizontal, you could think about it as rise over run, right? You want to? One question I wanted to ask you guys, if I had a vector that started here and was a straight line, it was not slanted, do you have to do any math or can you just count how big it is? You could just count, right? So if I drew this one in, 1, 2, 3, that'd be 4. The same thing with the vertical. If I drew a vertical straight up, 1, 2, 3, 4, this one would be 5, right? So if you've got straight line, flat or horizontal or vertical lines, then you just have to look at them and count. If the line is slanted, then you just drop in a rise and a run and use the Pythagorean theorem. Does that make sense? That makes sense. Okay. Position vector. When we find components of a vector and use them to define the vector, it's called a position vector. A position vector is represented by a small case bold letter. So all we're doing is, you're going to see this says PQ and they're calling it vector V. See how that is bold? So all you're doing to identify the vector is putting in the horizontal and vertical components. So if you look at this one up here, it was 5 and 2. So all we do is we write in 5, 2. That's it. So this is just how wide, how tall, right? And notice these little, those are not parentheses. They are pointy. I'm exaggerating that. If you draw parentheses, then someone thinks it's just a point, right? So we need the bent braces, if you will, so that we know that you're referring to a vector that's specific to the vector, okay? So vector notation. I'm going to ask you guys one more question. I wrote it on the next page, but with a vector, we want to know how big it is. We also want to know which way it's going. So I need to know this angle. What tool do you already have to find that angle? How would you do that? Well, this is opposite, this is adjacent. So how could you find the size of that angle? Tangent, right? So we can use our trigonometry. So go ahead and punch that into your calculator and see how big that is. Remember, what mode does your calculator need to be in? We're going to do a lot with a calculator in a couple of days, kind of fun problems, but you can punch that in and we can figure out how big that is. I don't know, I didn't do it. What'd you get? I got 21.801 degrees. Did you get that? Always, when you're doing a trigonometric function, keep 3 decimals unless your directions tell you to round. And even if your directions want you to give an answer rounded, keep 3 decimals through the entire problem for accuracy, and then you round at the very end if they want the 10th place. Does that make sense? So you know how to find the magnitude, it's Pythagorean theorem, and you know how to find the angle, it's inverse tangent. And you know, you type that in, right? Second tan. That's how you type it in, okay? I just wanted to see if you'd figure that out. I wrote it here. Direction of a vector, the direction is positive angle. I need you to notice that the vector makes with the positive x-axis. So your calculator can only find reference angles. We want to measure from here. So we may have to make a few adjustments if we're not in quadrant 1. Okay, when you measure a vector, you're measuring from 0. So even if it's over here in second quadrant, you're supposed to be measuring from 0. So let's look at how we'll do that, okay? I'm going to draw my little axes in. All right, so let's look at this. Where would the point 34 be? Right here, right? So this says it wants to find the direction and magnitude. So we always drop in to form a right angle. Of course, that's horizontal and vertical. Why do we want a right angle? So we can use the Pythagorean theorem. So you use your skinny bars and a bold letter, vector V. This represents magnitude. And in your notes, I know you know this one already because it's a 3, 4, 5 right triangle. But in your notes this time, it would be nice if you'd write all the steps out. So when you get one that isn't instant, you remember what you did. So this is the magnitude of vector V. Now we also need to know, remember that's magnitude. We don't have to write the word out. Our little symbols tell us that. We also need the direction. So what would the direction be? So we're going to do tangent, right? 4/3. So y'all type that in, right? You type in second tan, 4 divided by 3, and what do you get? 53.130. Again, unless you're told otherwise, keep those 3 decimals. Everybody okay with that? It makes sense? Are we good? Ooh, okay. Let's look at this guy. -2, 5. Where is that? Well, that's -2 this way and up 5. Right? We always go from the origin like so. So we drop in that right angle. So this is 5, this is -2. That's the theta your calculator is going to find because that's where you can build a right triangle. So let's find, again, what do these little bars represent? Magnitude, vector W, equals square root. Now, when I see -2 and I square it, do I have to think about the negative since I'm squaring it? I don't. So 2 squared is 4, 5 squared is 25. I think we're okay to already square the numbers by now, right? You wrote down here so you could see what happened. Now I need the angle. So let's do the angle, tangent. This time it's going to be what? 5/-2. So punch that in and tell me what you get. And you're going to notice something's off. -68.199. That's this angle. What angle do you want? You want that one because it's measured to the positive x-axis. So what do you think you're going to do to this number to fix it so it's actually this amount? Add 180 because you know that this red line is 180 and we know that this is 68.199. Now, why is it negative? What quadrant is that? Quadrant 2. And what is tangent in quadrant 2? Negative, right? Remember, tangent is positive going up because tangent means slope. So going this way, it's positive. Going this way, it's negative. So that makes sense. So you don't have to subtract 180. We can just add 180 and it's naturally going to subtract itself because it comes out negative, right? Since this is negative, we can just add and it's going to automatically subtract itself. So what do you get when you subtract those? And always look back to your picture. Does the 111 look right? Is that reasonable? It's reasonable from your sketch, right? All right. Vector U. What do you think's going on with vector U? Well, we want to find the magnitude. Remember to bold your letters. Okay, let's sketch that in. So that's -1, -2. right? And you always connect here and you draw your right angle to the x-axis. So this is -1, -2. There's theta. So I'm going to use my Pythagorean theorem. What's 2 squared? 4. What's 1 squared? 1. So that is the square root of 5. Unless they tell me, I'll leave the square root. That's an exact answer. If I type it into my calculator, it's then an approximation, right? So we like radicals. Now, how are we going to find this tangent guy? So we're going to say tangent. What is it going to be this time? -2 over -1. And what do you get when you type that in? Now that's this angle right here. But we want what? We want that. So what are we going to do to this number to make an adjustment? This is 63 degrees past 180. So what are we going to do? We're going to add 180. So what's nice about this is all you have to remember, if you're on the left side in quadrants 2 or 3, you just add 180. You don't have to subtract if you're in the top quadrant because the angle's going to come out negative. It will subtract itself when you just say plus 180, right? So all you have to do over here is 180, add 180 to it, and that makes the adjustment. Your calculator finds the reference angle for you, this little angle in here. All right, last one, vector x. X marks the spot. So how do you write magnitude? 2 skinny bars, right? And then a bold. So we got vector x. All right, so there's 2, 6. This is 2, this is -6. We're interested in theta. So we're going to have what? 36 plus 4. What is 36 plus 4? Can we simplify this guy? It's 4 times 10, so that's what? 2 square roots of 10? We do simplify radicals. It's still an exact answer, right? Now we need to find our angle. Rise over run. And what do you get when you type that in? I got -71.565. What do you think we're going to do? Because we need to adjust and we actually want that angle. We're going to add 360. I don't have to subtract because what's true about my angle I'm going to get from my calculator? It's already negative. Why is it negative? Because it's in 4th quadrant. What is tangent in 4th quadrant? It's negative, right? Because tangent means slope. And like we said here, if you're 2nd or 4th, tangent's pointing downtown is negative. So we just add 360. What do you get? 2. So let's think about that. If we're in 1st quadrant, we do our work, we're done. Everything's fine. If we're on the left side, we add 180 because 180 is our horizontal, correct? And if we're on the right side in 4th quadrant, we just add 360. It's always, I always recommend that you look at these numbers and stick that point and make a tiny sketch because that gets you into the right quadrant. Most common mistake, people forgetting to add 180 or 360, or they're like, do I add 180 or 360? If you'll graph it, you'll know, right? This one's close to 360, so you add 360. If we were over here, like we are here, we're close to 180. Does that make sense? Not hard, right? It's a little break from some of the stuff we've been doing. Okay, couple more little things and we'll be done. We need to be able to tell if I give you 2 vectors, are they equivalent, right? Are they the same size? All we have to do is subtract one from the other and see if the component form is the same. The thing you have to remember, let's highlight this. You have to take terminal minus initial. If you subtract backwards, all is lost. All is lost if you subtract backwards. So when we look at RS, which point is terminal? The S is terminal, right? So this is initial. This is terminal. Is it okay for you to write that down? Yes, I highly recommend you do. If we're looking at OP, O came first. This is initial. This is terminal. Remember, if you subtract backwards, you'll get the wrong sign and then you think things are wrong. Now, when we say subtract a vector, what parts do you think we're going to subtract? We're going to subtract matching parts, right? The X minus the X, the Y minus the Y. So fill it in this one so you can see. So we're going to take what? -1 minus -4, because those are these. And then if I put little red dots for those are matching, we're going to do terminal minus initial, right? So what are the numbers in this vector? Well, what's -1 minus 4? Minus -4, sorry. Right, so that's 3, and 6 minus 2 is 4. Now we're going to do the same thing over here and see if we get. So here we're going to have 3 minus 0, 4 minus 0. So that gives us 3. So are these, this is what you're testing. You're going to ask yourself, are those the same? Is 3, 4 the same as 3, 4? Yes. So that means these are equivalent. Easy, right? Not bad? It's not bad after trig identities, right? Let's check this one. We can go a little faster here. So we're going to say what? 0 minus -2, 1 minus 5. Over here, we're going to have -2 minus 4, -2 minus -3. Right? So what do we get here? 2, -4. And here we get -6, 1. Are these equivalent? Do these match? Are they the same? No. Any questions about that? That's pretty easy, right? Okay. Lastly, it's a good thing y'all are wearing surgical masks today because you're going to be performing some operations. You're dressed for the occasion. Operations with vectors. We can perform many of the same operations on vectors that we do on real numbers. To add, simply add corresponding parts, x's with x's, y's with y's. To multiply, just remember to distribute. I bet you can go through these with me without even needing help. This is vector u, vector v, and vector w. So what do you think the answer to 2u is? There's u. We're multiplying by 2. What do you think the answer is? Yeah, 4, 6, right? Easy? Nice math. Okay, a negative sign means take the opposite of w. What do you think the opposite of w is? 2, -1, right? Opposite means just to change everybody's sign. U plus w, that just means we add the x parts together and we add the y parts together. Make sure you look at the right vector. A lot of times your eye will take the two vectors next to each other, but this is u and w. So let's write down what we do in case you need to look at this. What are we going to do? 2 plus -2, comma. 3 plus 1, and that is what? 0, 4. Any question about that? That okay? We're good. We're good. Okay, lastly, now I would, if you have a minus sign, we want to make sure you don't double distribute. A lot of times people put 2 negatives in because they subtract and fix it and then they see the subtraction. So I would do this, right? And I would fix them and then I would subtract. So what's negative 2 times u? Negative 4, negative 6? No. Yes. Right? Yes. Minus 3 times v. Don't do the negative yet. Just do 3 times v. And that's negative 18, negative 9. Right? Now you can subtract. So we have negative 4 minus negative 18, comma, negative 6 minus negative 9. And now we can adjust those, right? And you get what? 14, 3. And you have completed your surgery or your operation. All right. That is it for today. I hope you're a vector expert.